Welcome back to section 3 of this video on sequences. This is still day 1 of your e-learning. This is the last section we're going to study today, but it is kind of long. What we're going to next do is find how to write a formula given a sequence is in the pattern. So if we have specific terms of a sequence, and we know that it's arithmetic, it has a specific way of writing its formula. It's outlined here in this box of important information. First, we're going to learn 2 ways of writing a formula. The first way is called the explicit formula. An explicit formula is used to find any specific term. So it is direct. It allows you to just plug in the location number for the term. So if I was looking to find the 38th term, I would just plug in 38 into a formula. And the explicit formula will tell you exactly what that term is without finding any of the other terms. The formula for an explicit formula for any general term in an arithmetic sequence is this right here. It has a couple of letters and notation that we're going to use. So we would just call this any term can be found by taking the very first term, that's what a sub 1 means, adding the difference n minus 1 times. So this could be a little bit confusing, and there's a note at the bottom that I have to read to you. It says this formula can and should be simplified. Our formula should be as simple as possible. If I go back to an exercise from above, like for example exercise 4, the third term is -9. So if I say the third term equals the first term plus the difference, now it says n minus 2. In this case the value of n was 3. I think I might have said n minus 2. I meant to say n minus 1, didn't I? At the bottom it says n minus 1. So I'll subtract 1. 3 take away 1 is 2. Negative 10 times 2 is negative 20. 11 plus negative 20 does make -9. So why does this formula work? In order to get from the first term to the second term, I added 1 difference. In order to go from the first term to the third term, I would add 2 differences. So if I wanted to get to the fourth term, I would add 3 negative 10s to the first term to make my fourth term. That's why this is n minus 1, or 1 less than, the term number, or its location. Because starting with the first term, you wouldn't add any differences. You would add, for example, 7 differences to find the value of your 8th term. What would you add it to? You would add it to your very first term. Getting to the bottom, now it says the directions. For each arithmetic sequence, find the common difference, the explicit formula for the sequence, and a specific term in that sequence. First things first, we know that each sequence we have below is definitely arithmetic. The directions doesn't leave any room for any doubt. This sequence goes up by 3s. So the first thing I want to do is write down my difference equals 3. The next thing is we're going to use the formula up above to find the explicit formula for any term. Any term can be found by taking the first term, whose value is 5, adding 3 how many times? Not n times, but n minus 1, 1 less than the term number. Now, the note from above says this formula should be simplified. So let's distribute our 3. Any term can be found by taking 5, adding 3n, and then subtracting 3. By combining our like terms, the most simplified version of this arithmetic explicit formula is 3n plus 2. This formula only works for values of n that are integers that are greater than or equal to 1. We can't plug in 0 in this formula because there isn't a 0th term. Also, the value for n has a domain of the positive integers, or also known as whole numbers. The value of n could be 1 or 2 or 3 or more, where n is an integer. So for example, now next, we're going to find the value of the 9th term. The 9th term can be found by plugging in 9 into this explicit formula and evaluating it using order of operations. 9 times 3 is 27. 2 more than 27 makes 29. The value of our specific term, the 9th term, is, I believe we said 29. So we found our difference. Our explicit formula is this. Oops, I circled the wrong thing. Our explicit formula is that there. This is what we use to find the specific term, the ninth term. One more time. Our difference is 3. Our explicit formula is this line here, 3n plus 2, and our ninth term was 29. Moving across to number 2. I know this is an arithmetic sequence because the directions told me. It's decreasing by 7 each time. So the difference, I'm going to put it up here this time. Our difference is negative 7 because it's a decrease. So next I'll find an arithmetic formula for this. We're doing the explicit one. What I didn't do last time, but I'm going to do this time, I'm just going to write the general formula, if I can get that right. I just need to copy it from up here. Any term is the first term plus n minus 1 differences. And then start plugging things in. So any term can be found by taking 21, adding negative 7, n minus 1 times. I'm going to distribute and simplify this. A sub n equals 21 minus 7n plus 7. And finally finish this off. Any term is negative 7 times the term number plus a 28. And this formula works when n is greater than or equal to 1, where n is an integer. Okay? Next, we are asked to find the value of our 13th term. The value of our 13th term is 13 times negative 7 plus 28. Let's see, 7 times 10 and 7 times 3. 7 times 10 is 70. 7 times 3 is 21. That makes negative 91. Plus 28 more, as the end of the sentence says. So I believe that's 63, but negative 63. Let me double check this. So if I add these together, yeah, that seems like it's that. Okay, so going back to the directions. The common difference is negative 7. The formula for the nth term is this down here, and our specific term is negative 63. We got 2 more exercises at the bottom of the page, and then we continue on to the next page. Question 3. This looks like it's decreasing by 66 each time. So it looks like our difference is negative 66. Write my general formula. an equals a1 plus d times n minus 1. Let's plug in the difference. Let's plug in our first term. And let's simplify it. A sub n equals 88 minus 66n plus 66. To simplify this, a sub n equals negative 66n. Let's see, 154 is what I got. This formula works for integers n greater than or equal to 1. Next, we have to find the value of our 7th term. The 7th term can be found by taking the first term and adding our difference 6 times. 7 minus 1 is 6. 6 times 66, that's 396. And what we're going to do is subtract that from 88. The value of our 7th term is negative 308. One more time, our difference is negative 66. Our formula, our explicit formula is down below. Our 7th term is negative 308. Go ahead and do the last one on your own. I'll give you a second to pause the video, then I'll continue. Did you find that the difference was 13? The values for your first term are 22. That's your first term. Your first term, your difference. Okay, so we'll do 22 plus 13 times n minus 1, the quantity. Distribute to simplify your formula. 22 plus 13n minus 13. Combine like terms. A sub n equals 13n. Looks like plus 9. For integers n greater than or equal to 1, I have to keep stating this every time I write a formula. Then it says find the 12th term. The value of my 12th term equals 13 times 12. 13 times 12 is 156. And then I'm going to add 9 to that. So let me run out of room here. So let's see, 10 and so I'm going to add 10 and take away 1. So 165. This is the value of our 12th term. I'm going to pause this video for a second and move to the next page. Alright, next we're going to do a recursive formula. Now a recursive formula reuses a previous term. It's very simple to write but not very useful. This formula always has two statements linked with the word and. You use the value of your first term to write the first line. The first term in the sequence is 25. When I notice this is arithmetic, again I'm going to use the values of a. Now we discussed that this is any term, this is the previous term, and that's the difference. So we still need to find the difference and the first term. It seems like our difference is decreasing by 17. So let's do this. These statements always start the same way. The next term is the previous term. This represents the previous term, the term immediately in front. And we're going to write minus 17. This formula only works where n is greater than or equal to 2 and n is an integer. For integers, n is greater than or equal to 2. Question 2. By the way, that was it. Question 2. The value of our first term is 221. So these all start the same way. So I can automatically fill in this much information every time I write a formula. First term, and the next term is the previous term, and then something happens to that. So I plug in 221. It looks like this is increasing by 7. Now this formula is recursive. We can use this to find the second term because we have a first term in front of it. We can't use this to find the first term because there's no term in front of there's no term previous to the first term. That's why we write the statement for integers. N is greater than or equal to 2. This formula only works as a pair of statements. Finally, the last two, I can again fill out the same information each time I do this, and this gets me going. Here goes. 31 is the value of your first term. This is decreasing by 9 each time. So the next term is 9 less than the previous term. Our last one, our first term is 69. The next term is the previous term. It looks like, what are we doing? We're adding 17. Sounds good. For integers n greater than or equal to 2. This concludes section 3. I'm going to share with you your homework in the message and on course. So please take a look at what your extra practice and homework will be. Thank you. Feel free to email me with any questions.